All right, everyone, the problem says, calculate the mass in grams of hydrogen chloride produced when 5.6 liters of molecular hydrogen measured at STP react with an excess of molecular chlorine gas. So this is a gas stoichiometry problem where we are given 5.6 liters of molecular hydrogen. So let's write that down. 5.6 liters, and molecular hydrogen would be H2. And the problem wants us to calculate the mass in grams of hydrogen chloride. So we want to turn that into the mass in grams of hydrogen chloride, which is HCl. So to go from liters or units of volume to grams or units of mass, we're going to need 3 conversion factors. So this will be a 3-step stoichiometry problem. So let's write those. Okay, and then for the first step, since we're starting with liters of H2, that's going to go on the bottom of our first conversion factor because we want to get rid of it. And we can convert that to moles of H2. So for our first step, we need to know the relationship between moles and liters for H2, for hydrogen. So the problem also gives us some more information. It says STP. We're at STP. That means we are at standard temperature and standard pressure. And that gives us a bit of information. At STP, we know that 1 mole of any gas has the volume of 22.4 liters. So at STP, 1 mole of any gas is 22.4 liters. So we're going to use that for our first conversion factor, where 22.4 liters will go on the bottom and 1 mole will go on top. And that will give us liters of H2 canceling out, because it's on the top and on the bottom, cancels out, and we are at moles of H2. So in the second step, we can take those moles of H2 and convert to moles of HCl. So what is the relationship between moles of H2 and moles of HCl? Well, we get that relationship from our balanced chemical equation, where we look at the coefficients in front of each of those compounds. So the coefficient of HCl is 2. So we'll put that up top with 2 moles of HCl. And then what is the coefficient in front of H2? Well, there's nothing there, and that means that it is a 1. A lot of times we don't write 1s in chemistry. So for every 1 mole of H2 that we react, we will produce 2 moles of HCl. So our units of moles of H2 will cancel at this point, and we have moles of HCl. So in our final step, we'll take those moles of HCl and convert to grams of HCl. And to do that, we need the molar mass of HCl. So for the molar mass of HCl, we're going to take the molar mass of hydrogen and add the molar mass of chlorine, because it's just HCl, 1H, and 1Cl. Okay, so we'll add those two together, and we get the molar masses from the periodic table. So for element 1, hydrogen, its molar mass is 1.01. So 1.01, and our units are grams per mole, plus the molar mass of chlorine. Element 17 has a molar mass of 35.45. So 35.45 grams per mole. Add those two together, and we get a molar mass of 36.46 grams per mole. So that is what will go into our final conversion factor, where 36.46 grams is on top and 1 mole is on the bottom. And moles of HCl will cancel, and we are left with exactly what we want, which is grams of HCl. So now we got to do the math. So let's get our calculator. We're going to start with 5.6, and we're going to multiply by the top of each conversion factor, divide by the bottom. We're going to skip ones because they won't affect anything. So we are going to first divide by 22.4. We're going to multiply by 2, multiply by 36.46, hit equals, and we get 18.23. Let's round that to two significant figures, and we'll get 18. Okay, so final answer. What mass in grams of hydrogen chloride would you produce if 5.6 liters of molecular hydrogen measured at STP reacted with excess chlorine gas? We would get 18 grams of HCl. All right, if you want to see another example, click in the top right. Please like this video if it helped you in any way. Feel free to look in the doobly-doo below for additional help and resources. Please subscribe and ring the bell to get notified for new videos. And thank you so much for watching.